Hey everybody, here's an introduction to movement and animation in Max. I have a planet model that I can bring in. I'll give it a material. And I've pre-made a few materials, so I can just do an import material. And that works because I have material files already created in my project. I'll add a light. And we can see that I have a directional light coming onto my scene. With jit.gl.light, it's one of the rare places where you can express color information with numbers larger than 1 to increase the brightness of the light. So I'm going to increase the diffuse to 222, which will brighten the light on my scene. And the first movement tool we're going to look at is jit.anim.drive. And this is a tool that allows us to run some simple animations. The only one we're going to look at today is the turn animation, which is a simple rotation around the center of an object. So this is rotating my planet and my moon in 3D. Now you notice that the center is being calculated as the center of this entire object, and that's because of the normalization issue we saw before. If we turn off normalize, we'll see now that the center of rotation is the center of the planet, because that's the way I built it in Houdini. So one of the nice things we can do is we can use the draw groups. We can use the draw groups to rotate different aspects of our model. So I can do draw group 1, which is the moon, draw group 2, and draw group 3, are the planet itself, and draw group 4 is the city inside the planet. And so right now it's odd because only the interior of the planet is rotating. So I will connect the jit.anim.drive to both parts of the interior of the planet. And just to get them in sync, I'll give them a rotate XYZ message of 0, 0, 0. So now both interior portions of the planet are rotating together. We can see I have my city and I have my moon. I have some more materials here to import. My city material, and of course my moon material. And one thing you might notice is that my city went dark when I applied the material. This is how fog works. Fog allows you to only reveal the details of an object as you get close to it. So taking a look quickly into the material panel, you can see I have linear fog with a fog density of 1 and a fog range, a very small fog range. In other words, the details of the object reveal themselves only between 1.4 and 1.32 meters away from the object. So as I could stop this rotation using turn 0, 0, 0 and return to rotation of XYZ. So as I move away from the object past 1.4 meters, it's enveloped in fog. And as I move towards the object, its texture is revealed. So that's a nice effect that you can use as you like. So I have my materials loaded in, and of course if this were a patch that you were creating, you'd certainly want to add a load bank so that those materials loaded automatically upon the load of the patch. So a nice thing to do with this would be to orbit the moon around the planet like so. We can see that moon is in a nice orbit. And if you want a simple orbit like this, this is a perfectly reasonable way to orbit your moon around your planet. But it's very limited. One of the reasons why it's limited is because you can't make this orbit any larger without making the moon larger. So if I, for instance, want to make the orbit 4 times wider, that also makes the moon 4 times bigger. And there's other reasons that anything besides the simplest orbiting situation can't really be done by the jit.anim.drive. So let's disable this moon for a moment. And you'll find this very useful. There's an enable attribute, which we've seen before in our jit.world, enable 1. Here, if we want to just make something disappear, we can enable 0 or uncheck the enable box in the attrui. And let's just add a sphere. There's our sphere. I'll make it a bit smaller. And that's what we're going to make our moon, so we can give it our same moon material. And in order to make that moon orbit our planet, we need to create a node, a jit.anim.node. And we'll make that right at the center of our world. So at position 0, 0, 0. And a node is an invisible marker. Why are we making this? Because we're going to rotate around that node by using another node, jit.anim.node, and we'll make that node some distance from the central node. We'll make it, say, 2 meters away, or, since this is space, you can think that's 2 kilometers away. We'll attach those nodes together and attach that node to the grid shape, and we see that our moon moves. But what happens? We lose our scale. Why? Because when you attach a node, an animation node, to an object, that node, in addition to controlling the position, also controls that scale. So we have to remove scale from our grid shape and add scale to our node. And now the moon is scaled back down. We've done this so that we can then rotate our central node And because our secondary node is attached to it at a distance, it's as if there's a bar between them. The moon will orbit as we rotate the central node. So I'll take the jit.anim.drive, give it the turn command, and now we see our moon is orbiting again. But now we can change the distance from the planet at which it's orbiting without changing the scale of the moon itself. If I change this to 3 meters or 3 kilometers, it's orbiting out there. Now notice it moves faster as it goes out, but that's expected because it needs to cover more distance in the same amount of time. So if we want to move slower, we can just turn down our turn, and it'll move more slowly. So why else is this node really useful? It's because if we don't want an orbit that's simply flat around the center of our world, if we want the orbit to be at an angle, we can rotate this entire frame of reference. What do I mean by that? This is an orbit that's going around the planet, and if I want it to be an orbit that's going this way, I can't simply change the way I'm turning it. I have to rotate the whole frame of reference. I'll do this with another node, which is also a node at position 0, 0, 0, but it becomes the parent node to the node that we're rotating. So for instance, if I rotate 90 degrees around the x-axis, now it's as if we're looking down on the circular rotation. If I rotate 90 degrees around the z-axis, now it's orbiting from bottom to top. And if I don't want to be so extreme, if I just want a tilted orbit, I can just give it a little 30-degree rotation, and that's going to give me a tilted orbit around the planet. So that's nice in terms of orbital motion, but how about moving in a line? Let's take all of this stuff, encapsulate it, and to go back in, load all our textures up, and we'll restart our moon and disable our other moon. And if I want that to be disabled by default, I can of course give it the @enable 0 attribute. And now when I load the patch, that original moon will not be enabled. So to start out with, let's just move a circle. There I've created this white circle. And movement in 3 dimensions is a little bit complex and actually not entirely beyond the scope of this class, but I don't want to have to teach you all the details of it at this point. So what I've done is I've created an object that's a helper object that will give you a lot of the features of movement without your having to dig in and learn everything that's behind them. And the object is called j.translate, and you'll find it on the Blackboard site. You'll also find it in the comments of this video. And in order to get j.translate so that it pops up as a usable patch in your work, you're going to need to go to the file browser, this double circle icon on the left. That pops up this window, and we're going to want to add a file to the search path. Click on that, it'll call up your standard file browser. You can navigate to where you've downloaded or saved the j.translate.maxpat, open it, and it will be added to the Max search path. So what j.translate does, you can look inside. It has a lot of stuff inside of it. It just takes care of some of the back-end work of animation for you. It attaches to an attrui. And for right now, we're going to attach it to the position attrui, but it works just as well attached to scale, rotation, look at. And it drives the position in a very simple way. You send it a message that has the coordinates x, y, z, followed by a time to get there. 1005. Click the mouse, and over 5 seconds, this shape travels to coordinate 100. I could travel to 130 over 2 seconds, and there it goes. So that's a very simple movement. And if you just send it, if you simply send it a message with 3 values, it will jump to the new location. So if I want to go to -1, -1, -1, I click and my sphere jumps to those coordinates. And then if I want to go back to 130 over 2 seconds, I click this message and it takes me back. So used in this way, it's a very simple animation tool, but it has a lot of additional features. It has an easing feature built in so that the animation can be smoothed in a variety of ways. To set up that easing feature, you need to create a couple new objects. So create a U menu and find the inlet that says attach U menu. And to start with, we're actually going to attach it to 3 inlets that all say attach U menu. One for the X, one for the Y, and one for the Z. And then the other object we're going to attach is plot tilde. And we can attach that to one of any of the outlets that say attach plot tilde. And to format both of these, we're going to attach this final outlet to the U menu inlet. We're going to put a button into the inlet that says attach button. Click to populate menu. We'll click that, and that populates our menu, and it also formats our plot tilde. And once we've done that, we can delete that button. That's just a setup inlet. And you can see here that right now we're using a linear transition. So when I go to a new location, if I go to -1, -1, -1 over 3 seconds, it starts, it moves at the same speed, and it lands. But there's lots of other transition types. For instance, a very nice one is in-out quintic. In-out quintic gives us a very slow start, a quick middle, and a very slow end. So watch the difference. Slow start, quick middle, slow end. In-out circular is similar, but it's a little bit faster as it starts up. That's also quite a nice one. And then there's ins and outs. So if you want the in to be curved, but the out to not be curved, so it wants to start slowly but end abruptly, that's an option as well. Starts slowly, ends abruptly. If you want to create curving transitions, all you need to do is set, and actually you can delete this cable as well once you've formatted your U menu. You want to set different curves for your X transition, your Y transition, and your Z transition. So if I am using, say, in-out quartic for my X, but using a linear Y and Z, watch what happens here. Right, I get this shape of curve on my X-axis. And you can see that works. If I do the in circular, I get this curve moving this way, and I'll get the reverse curve moving back. And if you curve multiple, dimensions, you can get some quite interesting curvature. Because it's a circular curve in its X transition, but it's a cubic in-out curve on its Y transition. So that gives you a lot to work with. But what it does also is it makes it much harder to save this information. Certainly you can create a bunch of message boxes and work with your different cues that way. And in the beginning, that's probably exactly what you'll do. But you're going to want to be able to store this information and recall it. So there's a wonderful object called preset. And preset is a bunch of storage positions for anything you want to store. All you do is connect to whatever objects you want to store. And when you shift click a slot in the preset, it stores whatever it's connected to. I'll make changes here and shift click slot number 2. And then when you normal click slot number 1, it restores the values. When I normal click slot number 2, it restores the values. And you can store a bunch of stuff this way. Shift click slot 3 to store it. Go back to 1, 2, 3. And also I can trigger this with messages. So I can send it a 1 to go back to state 1. I could also use a number box. By clicking on the number box, I could use the up arrow to go to state 1, state 2, state 3. So this becomes a very handy interface. The problem is message boxes cannot be stored in the preset. This does not work. So we need another mechanism to store the actual coordinates and speed. And this is, again, I've created another helper object for you called j.ms. And all that j.ms does is it prepares these values to be stored in a new object called a multi-slider. And multi-slider is an object that has a lot of different uses. The way in which we're going to use it today is just as something that can be stored by the preset. And j.ms takes an argument, which is simply the maximum value that you're going to send it. So for instance, if you're never going to exceed 10 meters distant from the center, or a transition that lasts longer than 10 seconds, use j.ms10. And if you discover that you are going to make a transition, say, that lasts 15 seconds, anytime you want, you can just up this to j.ms15. You don't need to worry about it. It just needs to be set to whatever the largest number you're going to use is. And so when the values are sent into the j.ms, it transitions. And a new set of values transitions just like before. The difference being that the contents can be stored in the preset object. So if we want to start here with this particular set of curves, and we shift-click the first spot in the preset to store it, and then we go to another location with a different set of curves, shift-click to store it. Now, both the coordinates and the curves are stored in the preset. Go to a third location, with, again, a different set of curves. If we like it, we store it in location 3 by shift-clicking, and now we can move back and forth between these locations. Go to location 2, go to location 3, or go directly from 3 back to 1. So those are all keyframes for our animation that are stored. Oh, one thing I neglected to point out before, this is a number box that does not have a floating point component. So it's not created with the F key, like a floating point number box that can express fractional numbers. It's created with the I key because it only has integer numbers. So this is an integer number box where we can step through different values with the arrow keys. So this is going to be very useful to you if you want to change an animation. Like, for instance, I don't really like that sort of knee in the middle of this animation. I can change it to something different. And then shift-click it again to resave it. Go to keyframe 2, come back to keyframe 1, and now that strange knee is gone. And you can store as many presets as you want, and we'll look later at how to make the keyframes happen at certain times or interactively. One of the things that I like to do with the preset is make the squares larger, which is the slot size, also called the bubble size. And you can increase that just so they're a bit easier to click on. So moving around this object is one thing, but one of the really interesting things that we can do is we can move the camera around. So we'll change this to a jit.gl.camera, and we're going to give it, for now, a fixed look at. We're going to say, look at the center, 0, 0, 0. Actually, we're going to look slightly to the right of center, and we'll see why later. And we're going to lock that look at. So lock, look 1. And even though we're in space, we're still going to mount this on a virtual tripod with the tripod 1. And we can actually clear out all our previous presets with the clear all message. And that's a dangerous button, so after you've used it, delete it just so you don't accidentally delete presets that you want to save. And let's start with a kind of standard camera position. Let's say 5 meters or 5 kilometers away from our planet. And we can jump there immediately. And I also got to reset my jit.gl.handle because that's going to interfere with my camera position now that I have an active camera at the scene. And I can take this and I can transition to pretty close to the center of the sphere, let's say over 5 seconds. I'll use that in-out quintic on all three so that I don't have any curve. I just have a straight transition. All right, and that gets me pretty close to the center. I want to go, actually, right to the center. Go back to my starting point. And over 5 seconds, I'm going to fly in to this point. I'm a little bit too close, so I'm going to back away. There, that's what I want. Just go back to my starting point and fly into the center of my planet over 5 seconds. That's a pretty nice effect. So I'm going to save both of these, and I'm going to give my starting position a time. Store that in location 1. Store this in location 2. And now I can, from here, fly through the planet to 0, 0, minus 5, which would be 5 kilometers past the planet. And store that as well. And now go back to my starting position, and I can step through this flight. Fly in, fly out. So that kind of thing is really where we're going with this, the ability to move the camera around and create drama and create a story through the movement of our objects and the motion of our camera.